2. Can I expand and contract log expressions using log properties?
Yes.
Yes. And by the end of this, you will use it. Today's, trust me, oh, it's so much better. It's the warm, pretty chill. It's going to give you a nice warm fuzzy for today. But then we got to make sure we go back and get the log. So there are 3. Yeah, awesome. You'll be fine. You'll be fine. So there are 3 properties of logarithms I'm going to use, right? I'm going to introduce a 4th that we won't use to expand or contract. How many people are using an older calculator, the 83?
Me. Well, I'm actually using the
Friends? Anybody else? Properties. No, yeah, you're not going to do it. Well, you'll still want this, Lucky, until you charge your revenue. So not a lot of people are using guys, so change the base formula that I'll show you at the end. It's still important, but we won't use it super actively. So the first property of log is the product property. I'm just going to write product, and you know it's the property. The second one I'm going to use is the opposite. It's the quotient. Whoa. Ashton, how's your notes taking going? Maybe turn all the way around in your table. That's good. Stop turning around and looking at Lucky and Friend. And then one other one, guys, is the power property. So the product property states, okay, so if I have a log, base b, right, and if the log base b of the number I'm taking is 2 things being multiplied, so n times n, so log base b of n times n, doesn't matter what b is, right? I can split this up. It is equal to, I'll get the same thing as log base b, so same base of m plus log base b.
What is that thing next to the n?
Plus sign.
N plus log.
Is that right here?
Oh, no,
it's n. M times n. So log base b of m times n. Hold on. Log base b of m times n. I can split that and make that log base b of m plus log base b of n. Yeah.
M times
It's just m and n are two. M and n are two numbers being multiplied, guys. If you want an example, like down here, we'll do that. Log base 6 of 2 times x.
But it looks like it's like log b. Is m times log b, or like the power of b?
No, it's log
to the power of m.
It's not a power.
What?
Here we go. So the quotient, guys, I'm going to blow through these, and then we're going to do some example problems. All right. So similarly, if I have log and then a base b, right, and if they're being divided, m and n, so my 2 numbers, n divided by n, right, and maybe it'll help if I put these in parentheses.
Yeah.
Will that help? So when I had a product, if they were being multiplied, I added them. What do you think I do when my numbers are being divided? Subtract, right? So this was equal to log base b of m minus log base b of n.
I remember when math was numbers.
All these logs.
No, that's kind of funny, Christian. Thank you, Cole.
Good. So power, guys, this is the one that's not tricky. It's just it's different. You don't really have an opposite. What's up?
That's a b on the 6, I think.
Yeah, it's a b. Log base b. Yeah, I'm not doing any numbers.
I've been writing 6.
Yeah. So with a power, if I have a log base b, and if I have m, and this is where you're going to want to pay attention, I have n raised to an n power. So that's my power property of log base b of n raised to n, hold on. I can take that n, that exponent, and move it to the front as a coefficient, so n times log base b of n. Are there questions? I saw hand shoot up immediately. Vince first.
So it's the log of base b
Right.
times n.
Well, not times n to the n.
And power.
But like
Yeah.
just the way you're setting it up.
Right, so the way I'm setting it up, log base b of n, but n is raised to a power, right? So, if guys, if you're looking at this and it's very abstract, I understand. We're going to do these example problems, and this will help a lot. But like, I've got a log, it's base 10. I don't write that 10 because it's a common log, right? Log base 10, 3x squared. That's 3x raised to an exponent, right? Well, not the 3 isn't. The x is raised to an exponent of 2, right? So we'll get to that and I'll show you. I think doing some example problems will help, guys. It honestly will. So those are all you need. That's notes. I want to do some example problems, make sure we're good. We'll expand some into multiple logs, and we'll take some multiple logs and we'll contract them down to one. We say condense to probably use condense. So rewrite the expression as multiple logarithms. Log base 6. Look, my 6 is totally different than my b.
Wow.
First off, so that's a 6.
I know. Yeah.
We use like a different.
It curls over. Can you tell? Log base 6 of 2x, right? So I want to split this into multiple logs. So I've got a 2 times an x, so an n, one number, times a different number. So I can split these up and do what with my logs, Lucky?
Log b 2 plus log b x.
But what's my b here? It's 6.
Oh well, yeah. I looked at it. I thought it was.
So this is equal to, guys, I know, log 6, I don't know how to make my 6 should I guess curl over more, like you should go more up and down. Log base 6 of 2 plus log base 6 of x. And that's literally my answer, guys. I'm just,
That's not be as hard as this ever gets.
huh? It's going to be slightly more difficult, but it's actually not so much. So that's all it's saying is to rewrite it as multiple logs. Good. All right, so this next one, log base 2 of x over 3. Which property am I going to use here?
Quotient.
Quotient property. So I've got log base 2 of x over 3. Log base 2 of something, right? Minus log base 2 of something. What comes first?
No.
What? The n.
Look back at your m over n and what order they went in terms of subtraction.
Yeah, I was right.
Right, x is first, and then 3. Yeah. Unless you put negative log base 2 of 3 plus log base 2 of x. In that case,
Is that the
Yeah.
associative property?
no, it's the quotient. I mean,
So like, when I wrote on my paper like the log base m of n, I wrote it to look like an exponent. It's not an exponent.
for what?
Where should it go?
For which property?
So like
For the power property. Yes.
Should it be like log base and then n?
Right, that's your product property.
Or is it
Ooh. No, they're not exponents. They're not both exponents because for my erasing. Hold on.
Excuse me, you have Christian Lewis.
Yes.
He needs to come to the attendance office to leave.
Okay, thank you.
You're welcome.
Thank God.
Is this easy? No, it's a log,
Oh my God.
log base b, and then my n, or whatever the number it is always going on the same as that, especially because I guess my power property, n is an exponent to n. Right? Yeah. All right, back to it. Was there another question? Amelia, Christian's leaving. Hannah.
so they're not supposed to be drawn?
No, and for those of you who missed logs, right? No, the B is my subscript, right? So it's a small, it's the opposite of an exponent, so instead of being raised up, it's smaller below, and I know my handwriting's pretty awful. But like looking at this log, for example, my B is my subscript, small down below, right? 2x is, so it's not 6 raised to the 2x. It's log base and then my number, right? And then I can have an exponent on that number, for example. This next one, log base 10. I know it's a base 10 because it's a common log, right? Let's leave with a little dignity. Let's see, like, dignity gone. Then it's even deeper. Log base 10 of 3x squared. So guys, so I've got 2 different properties here that I can deal with. What's the first one? Or there's really no order, but I've got a power property because I have an exponent. What else? Product, because I have 3 times x squared. So here's the deal. Split them up first, your products, right? And then deal with your power. So if I split these up, I have log of 3 plus log of x squared. So now I've got a power property, right? Now here's the deal. This rewrite as multiple logarithms, this is technically an answer, right? This I would accept this. You've rewritten this, you've taken one logarithm and written it as multiple. I didn't say with no exponents or anything like that. But I'm going to ask you to go the next step, right? And change this to, I've still got, log of 3 plus what? What am I going to change log of x squared? You were here 30 seconds ago, though. Which property am I going to use for log of x squared? Power? So what am I going to rewrite it as? Log of x squared.
2
Log of x, right? Good. And I know you weren't here, so like, what the heck's a log? But it should be. Okay. Makes sense, guys? Yeah.
So since the log there doesn't have a base, there's no.
What is the base?
10.
10. So it has a base, we just don't write, right? Common log on your calculator, on worksheets, on quizzes, on homework. If they don't show you what the base is, it's 10. Now, if they put a natural log, ln, they still won't put a base. But on ln, what's my base always, Trent? Oh, it's e, so that was not the answer to my question. What does 10 have anything to do with it? What's what?
Where did 10 come from?
Alright, condensing. Which of the following is equivalent to log 9 plus 3 log 2 minus log 3? So all my answers are condensed down to single logs. So if I can do that with this 3 log thing, condense it down to 1, I should get an answer. So I see 3 different properties I'm going to use. I'm going to use all 3 of these here. I've got a plus. That means I'm going to use the product property. I've got a minus, meaning I'm going to use my quotient property. I've also got this coefficient out here. What am I going to do with that coefficient?
It becomes an exponent.
Yeah, it becomes an exponent, right? So let's do that first. Let's change my power, all right? Then let's do, I don't know, then we'll do the sum, and then we'll do the difference, right? So first, I'm going to change this to log of 9 plus what? What am I going to change 3 log of 2?
3 log of 2, would that be log of 8?
I was getting 8.
Because you take the 3,
Like an exponent, right? So he's saying, oh, I forgot to put the number 9 in there. So log of 9 plus, Trent gave us log of 8. And the way he got log of 8 is he took the 3 and he moved it as an exponent on 2. And 2 cubed is 8. So I'm going to leave it like that, 2 cubed, and we'll change it to 8 in just a minute, minus log of 3. Good, so let's condense these. All right, what am I going to change log 9 plus log 2 cubed What you got, Brent? What do you think? What am I gonna change log 9 plus log 2 cubed? They're being added, so which property am I gonna use? Product. Good, so I'm working in reverse on my product property. Good, so what do I want to change it to, Brent? Down to one single log. Okay, good start. No, we already did that. We already took the 3 and moved it over here. Okay, I'm being added. Anytime I'm adding logs like this, Brent, I'm going to multiply. So 9 times 2 cubed. You got that on your notes? That if I got 2 logs that are being added, I can take those different numbers and just multiply them. So log of m times n is log of n plus n. So I'm going to have log plus log 2. Right? So I'm going to take those and say 9 times down to one single log, right? Yeah, good. So log of 9 times 8 is log of 72. Good. Minus log of 3. And then Ashton, what am I going to do with these two? I need to get down to one single log.
Give me a second.
Which property am I going to use? Go with that first.
So like, I don't know how to say which one it is. I know which one I want to do. I don't know how to say it.
You don't know like how to pronounce the word?
Well, yeah, like, is it? Yeah.
No,
No, sorry. Okay. The power button. It's the power.
The power?
Yeah, what?
Why do you think I'm using the power?
Shut up. Because they're both powers.
What's happening with my logs? Are they being added, subtracted?
Oh.
What am I doing with them?
Never mind. So you're gonna for quotient. I can't read my handwriting.
You can't read your handwriting? That's a problem. I can't help.
Yeah.
They're being, so I'm going to use quotient property. Actually, they're being subtracted, right? So I want to rewrite this as one log. What is that log going to be? Use your quotient property. Get it up there.
Yeah, I don't know. You multiply the log.
No? Trent, you know?
But like on quotient, it says like M and N, but I don't see
M, N.
then where's B?
It's 10, right?
Oh, okay.
It's 10 because it's not there. And B doesn't even matter, as long as they're the same.
So it would just be
Log of 72 over 3. Which is what? Log of 24? My answer is B. See that trend?
Yeah.
I think a lot of us might be overthinking this. The B doesn't really matter as long as it's the same for all my logs. And again, I said I'm probably not going to throw that curveball at you. But, there's no way to work with them if they have different bases. You literally just say, nope. Yeah.
So the log does have a number. So if it was like log to the 6th, 72 minus log to the 4th, 3, would you just multiply those two numbers?
No, you can't change that B, you mean? No, you can't do that. That log of a base is a totally separate operation.
But that's B.
It would just, you couldn't do anything. Yeah. That's what I'm saying. If I give you,
Does that change it?
if what?
They're the same log. Like log to the 3rd.
Log base 3 and then log base 3. As long as they're the same base, you can do all these operations.
Why these don't have it, so that we can do log.
Well, no, remember, up here, I have log base 6 and I split it up. Here, this will answer your question. Let's do this guy here. Rewrite the expression as a single logarithm. So on all of these, Trent, notice that I don't have a base written. Hello? So rewrite the expression as a single logarithm. I'm erasing this so I have a little more room. So I have log of x, guys, I have log of x plus log of y squared minus log of z. So I don't even have numbers here, all variables, right? I see all three properties in there. You see that y squared for my power, and then I see a sum and a quotient as well, or product and a quotient, right? But, so I could change that y squared to a 2 log of y, but honestly, it's not going to make a difference. So I'm just going to leave it for this. So honestly, what's going to happen with these guys? That's going to become log of what? Log of x plus log of y squared. Log of x times y squared, right? And then this whole thing is minus log z. So what do I do with z? Divided by z. And that's it. If you can simplify, folks, if you can simplify, do it. But I definitely can't simplify this at all. Right? I mean, if I had an x on the bottom, they could cancel out, but I don't. Cool. Do the, hold on, no, actually, the next one I'm going to show you. No, I take it back. Try it on your own. Good. So, this one wasn't bad, right? I think most of us did that pretty well. It's just a natural log of 2 plus a natural log of 5. So I'm going to change this, just that guy, to ln of 2 times.
That's an L?
No, 2 times 5.
That was an I.
That's an L. Oh, it's L, natural log.
It looks like
Or log naturel. I think it's French. But
I'm French. Wait, I speak French now. I'm actually, I'm not French. Wait, so that's not I.
it's an L. It's so long. So ln of 2 times 5, which is what? 10. So let's just change that. And I'm going to get rid of that parenthesis too. So ln of 10 minus 2 ln of x, right? So this is where some of us got into just a little iffy, right? Before I do this quotient subtraction property, before I do that, I need to deal with this too. You can't have, we didn't talk about this and how I am, you can't have coefficients on your logs when you're doing these properties. They need to have the same base, and they can't have coefficients on them. So to get rid of that coefficient, what am I going to change to natural log of x? This is just ln of 10 minus natural log of x squared, right? Just like I did up here, when I took my 3 log of 2, I take that 3, and I make it my exponent. So down here, I took the 2 here, and I made it my exponent on x. So this is subtracting, so it's a quotient property, natural log of 10 over x squared. Well, I don't walk around and check to give you points or anything like that. No, I want to make sure it was
0 points.
Well, you're right. You're lucky I don't, actually. Seriously. Like,
I suck.
what's up, Colin?
Bro, this is why is it, I don't know why it's always, like, down to it's an extra.
Answer for this guy, log of x to the 5th over y to the 4th. Asking the way I do this, I'm going to take each of my coefficients, I'm going to move them as exponents. What, that this is an x and that's a y? No, the only thing that I care about is that my bases are the same. And they are, right?
I thought they had to be the same.
No, just my bases have to be
That's
the
why I
same.
was lost.
So this is log of x to the 5th minus log of y to the 4th. And again, my
Did you
bases.
just get rid of that negative sign?
What negative sign?
The minus?
No, since my 2 different logs are being subtracted, I use the quotient property. Right, Colton? You said that. You said it's a quotient property. So they're being subtracted.
Okay.
So when I change it to 1,
If you're adding it, it would be.
that's this divided by this. The log of x to the 5th over 1.
And if you're adding it, it would just be log of x to the 1.
Yes, yeah, if I was adding, I would just multiply. Good. Good. Right. Actually, I use. Alright, how many people said they had an older calculator?
Lucky.
Right, so here's the deal. I do want to show you this. I want to show you this change of base formula for the older calculators. And if you're ever just stuck with the scientific, this will be good. You'll know how to do this. This will also, I'll show you how to do this without the change of base with the new fancy calculators. It's super easy, and you'll wish you had a new one. Maybe you wish I had one when I was growing up. So the change of base formula, guys, it's the same kind of basic thing for logs. Y equals log base A of X. All right, and guys, while you're writing this down, listen to me very closely. Write this down. Don't get this confused with any of the properties we did where we were using these to expand and contract expressions. We won't use this to do that. You're only using this when I give you just a basic log and it says use your calculator to evaluate. And for those of you with new calculators, you don't even need this to do that, but I want to show us. So if y equals log base A of x, I can find that by doing a common log, which is base 10, right? Can you hold on? Just wait a second.
Can I ask a question about that?
Well, but I'm not done with it. Hold on. Log base 10 of A, and I'm not going to write that base 10, right? Over log base 10 of X. This is important because on the older calculators, there is no way to plug in a log and change its base. You have to do base 10 logs. It's the only thing the old calculators can do. So some genius along the way said you can figure out any log by using the change of base formula.
So that X is not an X. That's
No, that's just on the same line. That's just log of a number. It looks like this, right? Log base 5 of 8. So in our calculators, so everybody get them out. On the new calculators, if I want to do log base 5 of 8, I can't hit that log, because that's log base what? 10. Useless to me. However, on the new ones, if I go to math, and I go to option, I think it's A. Yeah, option A that you can't see. Keep going down. It's so hard to see. Option A is log and then in big capital letters base, right? It has to do with you'll use change of base formula. This is for you as well. Hold on. So I'm going to show you how to do it without this in just a second. So for us with great fancy calculators, guys, if I hit enter on log base.
Can I see Jillian Hands in Mrs. Scott's office, please?
Yes.
Thank you.
Jillian, can you wait 2 Okay, go ahead. I was going to say, I'm almost done. So guys, when I choose log base, you can't see it on mine, you can see it on yours. It's already flashing at where B is. So log base 5 of 8 is just a matter of touching 5, moving over, pressing 8, and hitting enter. What'd you get? 1.292. You can read it. Useless. Oh, I hit.
Oh, I see. Can you just round to 3?
I don't know if that'll help.
Oh,
That hurts it.
yeah.
Turn the other one.
Hold on.
Wait for it. Hold on.
You already went.
Just turn them all on.
Oh.
Up. It's exactly the same. Just turn them on.
wait, what if?
No, there's two. You want to turn them all on?
Yeah.
No.
Oh,
Hey, turn them all on.
I felt like turn all
I'm not worried about it. I'm not worried about it. So that's the easy way to do log base 5 of 8. For those of us with old ones, guys, change of base formula. So I have log base A of X is log of A over X. So I'm going to split this up into change of base. I'm going to say log of 5. Wait. No, your base is on the bottom. I told you this backwards. Sorry. I know, it's just backwards. My bad. Big surprise, Mr. Jackson messed up. log of 8 over log of 5. My bad. If you want a way to remember that, for those of you doing change of base, your base, the small number, goes on the bottom. So the number that's small and on the bottom of my log is on the bottom of my change of base. You what?
Are you able to like one point
Yeah. What do you mean update?
like it's like you have to have like an update.
You don't have change of base?
You have to plug it in and then buy it on the computer. Like you have to buy the update.
Yeah, you don't. Oh my god.
No.
Yeah, I have no
In
idea.
school, my
If you have written it on your calculator and ours and click.
I'll email some people to find out. We'll get it out. But for now, you can still do change of base. So if you get log of 8 over log of 5, right? So without using the big fancy calculator buttons, I can still do log of 8 divided by log of 5, and I should get 1.292. And I do.
that was way quicker anyway.
Yeah, I mean, the nice thing about doing that, guys, is it's real simple, and you just have two quick little numbers to press in. Using change of base, you don't have to go into the math. You don't have to worry about your calculator being updated. I want us all to be able to do this, but I'm not going to make you do it on the test. I'm not going to say, and you have to use change of base and show me. No, whatever you need to do to get the right answer, right? So,
Question.
yeah.
When you're doing the log over log, you have to let the log every time.
You mean like as you're writing it out?
Yeah, log,
Yeah.
log.
Otherwise,
You
I
just write
don't know.
log, then
I need to see the log. All right, do the other two. Give me answers on those. This one's what we say, 1.292. Do the others, the other two.
Or one.
Hold on, 1.27, which we can run 1.27, 1.269 is fine.
1.3.
And then for C,
0.67.
0.67, 0.674. I'm okay if you rounded that. Cool. You'll get the same answers with change of base as you do for changing the base yourself on your fancy calculators. When I was growing up, in between walking to school uphill both ways, I hate that so much. But when I was growing up, we had like it was always change of base. And I think I remember senior year, one student in my class had a fancy calculator. I was like, why is this any different? And they're like, honestly, the only thing that I really care about is logs. And the teacher was like, oh, this is great. I'm going to have to teach change of base. Anyways, we all had to do it, always.